This last video is going to look at applications of radical equations. And so applications are the mathematician's way of saying word problems, but we're going to not use so many words. First example here is just going to look at the Pythagorean theorem. Really, that's all this is. Okay, and all we want to do is solve for b. So this is currently solved for hypotenuse. We need to solve for a leg. And so you would square both sides, right? Square, okay. And so we end up with c squared is equal to a squared plus b squared. Move the a squared over, c squared minus a squared is equal to b squared. And then square root both sides. And I will include the plus and minus for formal correctness right now. But when we are in the context of a right triangle, we would only go with the positive because we can't have a negative length. Okay, so there we go. One application problem done. Another one. So if we look at an object that's in circular motion, the force that is on it is called centripetal force, and all we need to do is solve for this v. Okay, it looks like nu, but it's a script. It's just a cursive v. So here we go. And so let's see, I need to multiply both sides by r. If I do that, I get fr is equal to mv squared. And now, again, the square is only on the v. I need to isolate the v, divide by m. Fr over m is equal to v squared. And I'm going to come up here to finalize it, square root both sides. And for right now, I'm going to say v is equal to plus and minus square root fr over m. Typically, and you would need to know more about the context, but if we're talking about just speed, we're probably using just the positive. So again, context will dictate whether to use both the plus and minus or just one side. Okay, so that one, again, not too bad. Now this next one, yeah, you look and you're like, oh my god, there's a lot. But really it's not. It's just telling you what all the crap in the equation is, so don't get scared by all the words. Okay, pay attention to what is being asked of you. Solve for r. Okay, r is right there. So I need to move the gm to the other side. I'm going to multiply by gm. So I have t squared times gm is equal to 4 pi squared r cubed. And next, let's see. So I need to continue to isolate the r. So, divide the 4 pi over t squared times gm over 4 pi squared is equal to r cubed. Okay, and then again, you need to solve for r. R is isolated, but it is not solved. So introduce the cube root to both sides, or equivalently the 1/3 power, whatever floats your boat. T squared times gm over 4 pi squared, and then cube root of all this is equal to r. Okay, and that's really all that there is to it. Again, you could simplify if you had any exponents that were greater than the index, but here all the exponents are 2 or less in the radicand, so don't worry about it. And that's really all that there is to applications. Solve appropriately as needed, and have fun with word problems.